Okay, looks like everyone has joined. So I'm just going to give a quick welcome. My name is Dominic Bird McDevitt, and I'm the Director of Community Engagement here at DPLA. And on behalf of DPLA, I just want to welcome you to this webinar. We're really excited to present this topic um, because here at DPLA, we're all about leveraging our position as an aggregator and a convener to help increase access to our nation's digital cultural heritage. And while it's always been important, the last few months have really highlighted the importance of resilience in our field. And so that's why I'm really happy to present this pilot project with the Filecoin Foundation, which represents one form of digital resilience, using the decentralized web to ensure enduring access to stored cultural heritage. So just as some housekeeping, we invite questions and have time to answer them towards the end. The talk is going to be recorded. We're in a webinar mode, so audience participation is restricted to chat and Q&A, which we'll be monitoring. We're going to hear later from DPLA's Director of Technology, Michael Delabina. First, I want to introduce our main speaker. So Jefferson Sankara is a senior software product engineer at the Filecoin Foundation, where he leads the development of Singularity, the only open source end-to-end data onboarding platform for the Filecoin network. With over a decade of experience in product management, data science, machine learning, and blockchain technology, he specializes in creating tools that empower organizations to preserve, discover, and derive long-term value from decentralized storage networks. In this webinar, Sankara will share insights on how libraries can leverage Filecoin's decentralized storage solutions to preserve data securely and reliably. His unique blend of product strategy, technical expertise, and passion for decentralized systems makes him an invaluable voice for libraries exploring Web3 technologies. And I'll hand it over to Sankara.
Thank you so much for that introduction, Dominic. Welcome, everybody, wherever you're joining from across the country. Good morning, good afternoon. Today's chat is going to be about leveraging decentralized web to preserve America's cultural heritage. And here's just a quick overview of what we will cover today. We'll begin by exploring why cultural heritage preservation is at risk and what threats we are facing. From natural disasters to digital fragility, we've seen wildfires in the last few years across the country. And then next, we'll explain what the decentralized web is, introduce decentralized storage, appreciate key concepts like IPFS and Filecoin, and then we'll attempt a comparison of decentralized storage with traditional cloud system, especially in terms of permanence, verifiability, and openness, which I believe are important considerations for you guys and for your work. And then from there, we'll dive into real possibilities and opportunities that this infrastructure opens for preserving cultural assets. And then we'll take a look at how you can get started using tools like Storager, which is very good for smaller files. And then we'll talk a little bit about Singularity, like Dominic mentioned in the introduction. That's the product I own. And then, of course, we'll also be transparent about the challenges we've been facing, because it hasn't been just a smooth sailing. We've had some setbacks and challenges, but through partnership, support, providing feedback, and closing those loops and gaps, we've been able to overcome them. And then we'll take a look at IPFS and Filecoin in the real world, showing, this isn't just theoretical. Yes, it is an experiment. It's a project that we're developing. We're building a new paradigm of the internet, but it already has utility, and there are folks who are using it. And then finally, we'll invite you to get involved. You will understand and know how you can be able to connect with us and get in touch with folks in the ecosystem, just in case you're interested in exploring the technology or uploading data. So like I mentioned, let's begin by just grounding ourselves in the why. Why does cultural heritage require a different kind of protection in the 21st century? And like I mentioned, we've seen, physical threats ranging from floods, fires, earthquakes. Like natural disasters have just wiped out centuries of histories, and they can't do that in a moment's notice, or maybe even without notice. And in recent years, hurricanes, wildfires specifically, have shown us just how fragile our archives can be. But there are human-made risks too, right? We are familiar with budget cuts. We're familiar with political instability, sometimes even negligence. We've seen libraries and archives shatter or get underfunded, leaving digital assets without a custodian or a caretaker. And obviously, there's that inherent digital fragility with the current internet paradigms, where you have certain file formats going obsolete, storage media degrading, technology just evolves, and you find certain things are no longer relevant, and they can no longer be supported. So what can we do then? So libraries, to me, have always been more than bookkeepers or book repositories. Really, I look at libraries, and especially with Web3 in mind, as guardians of our collective memory, our history, our culture. Culture is coded wisdom. So if you have folks preserving that, you're definitely preserving the wisdom of a community. And in the digital space with Web3, the web increasingly being read, write, and own, folks having ability to control ownership of their digital assets. I'm looking at libraries evolving into digital custodianship, not necessarily digital librarianship. So what is this decentralized web? If we could just shift gears to a possible solution to what we've appreciated in the first two slides. The difference really in this paradigm of the internet is in its architecture. So instead of relying on centralized data centers and corporate-owned platforms, it runs on peer-to-peer networks. Data is distributed across nodes, which eliminates a single point of failure. In a decentralized space, users power the network. It becomes inherently resistant to censorship. It becomes inherently resistant to just a single point of control and failure, obviously. And it gives us more control. It restores privacy and gives us ownership as well. So these values aren't just technical. I think they represent a shift, a philosophical shift, if you may, and they mirror libraries' values of equity, access, autonomy, and stewardship. Let's look at the contrast, like I mentioned in the agenda. On the left side, we have Web 2 paradigm. We see predominantly today, this internet is centralized. You have a few players, you just have a few entities, Google, Amazon.
Sankar, can I interrupt for just a second?
Yes.
For some reason, it seems like we're only seeing your first slide. We haven't seen your slides move forward.
Oh, I am on slide 5. Well, all right. They're moving, they're changing.
No.
All right, what I can quickly do is stop sharing and then share. I apologize for this. Do you see my slides now?
Yes, it looks good.
And they're moving, they're changing, right?
Yep, everything's great.
All right, thank you so much. We were slide 5. There we go. Yes, I had mentioned that we have a few entities, we have just few corporations or players that really store all our information. They control our lives. If you're even thinking about social media, you could name a handful of entities, and between those entities, you have everybody's interactions, you have everybody's data. Everything is just controlled by a few people. This is obviously risky. We've seen in the past some of these services going down. We've witnessed outages of services like WhatsApp. Facebook, like the entire thing just goes down because the infrastructure that is supported, which is centralized and it's centrally controlled, when it goes down and there are no alternatives, that service, you have an outage. So a useful solution, or at least an attempt to this solution, is decentralized and distributed web. Distributed is quite difficult to achieve. Decentralized, however, is something that a lot of projects, including Filecoin and IPFS, have achieved and have attained. Again, just the peer-to-peer architecture, no single point of failure, the transparency and control for content owners, especially. This is really important, and very shortly we're going to appreciate how IPFS and Filecoin brings about this. And something very important to just mention, you'd think maybe a solution to today's internet, like avoiding a single point of failure, would be just adding, a bunch of layers on top for business continuity and stuff like that. But the inherent design of the current internet being location-based addressing, you have URLs. Like if you want to do anything on the internet today, and we're going to appreciate this in the coming slides, you have to know the location of that file. And if that file is moved by somebody for whatever reason without updating the location, then it's just difficult to find that. The inherent design of how HTTP works and how access to locations work just makes it difficult to resolve the issue by adding, layers of high availability, business continuity, just to prevent one node from going down or one setup from going down and ensuring another one kicks in. This is obviously a practice that goes on in IT and in Web 2 today. Like folks have high availability business continuity plans and stuff like that, but you still have services outage and everything just going down. Now, the solution to this is the decentralized space, IPFS. That is the solution to this. So what is IPFS really? What is interplanetary file system? What is a file system? A file system is simply files and folders, right? It could be any content, any format. That is a file system. Why interplanetary? The attempt was to actually conceive a way of upgrading the internet in a manner that if the network traversed across different planets, this network should still be able to support interaction. It should still be able to support collaboration and communication. Folks should still be able to send files between Mars and Earth. And here, the concept is really simple. If somebody was in Mars, for instance, and you wanted a file that is on Earth, you send a request. That request could take a few hours before it gets to Earth, and then the response is beamed back to you. However, if somebody else if you're leveraging IPFS in that scenario, and somebody else had pulled that file and there was a copy on Mars, the request need not be routed to Earth before you can get the response back. Your request would simply be routed to the node or to the person that is next to you. And that is the whole concept of decentralized technology and this peer-to-peer networking. You could have Michael with a node, Dominic has another node, and I have a node, and we can, in a peer-to-peer manner, exchange files, communicate without a central authority controlling how we are doing that. And so in the IPFS world, if you take a look at the process, like I was mentioning, really, anything that any file that you access, be it from your computer, file has been created, saved to the drive, it is saved with the path. So you know where it is, the location itself. And that is just common for Web 2. Anything that you can think of on the internet today, you simply access files, you simply open files. And these files are usually, most of the time, they're usually in remote locations. They could be hosted in the cloud. corporate server somewhere, you don't know, social media server, data center somewhere, they're just remote files and you're opening them and leveraging the browser, which just makes things pretty, but it's no different concept really from you opening or accessing a file in your computer. Now you need that path, you need that address. With IPFS, it is a content. So it is content addressable. You have to know the content before your request is routed and the files are accessed and retrieved. So instead of having the address and the location, knowing the location, you need to know the content. And we'll see why this is useful. So you could think of this as a peer-to-peer version of HTTP. Those of us who are familiar with HTTP protocol. IPFS is a peer-to-peer version of HTTP. And like I mentioned, we need to create identifiers for each piece of information that we want to put on the network, IPFS or Filecoin. And the content is cryptographically hashed. So you can think of this as a kind of a cryptographic fingerprint that represents every piece of content. Every piece of content produces a different fingerprint. If you make alterations to the original content, it will produce a different cryptographic fingerprints. And all the fingerprints are the same size, regardless of the amount of content that they represent. And if you provided, if Michael, for instance, had an image or had any data set and provided that data set, used a different tool to generate this unique identifier, and then provided the same image or the same piece of data set to somebody using the same tool, just provided the chunking algorithm is the same, they would end up with the same content identifier or this cryptographic fingerprint. So it is useful, and we're going to appreciate concepts like deduplication. It is useful in the sense that it avoids a repetition of keeping two identical copies of two identical files. As long as there's a fingerprint or there's a hash, this CID, we call them CID content identifiers. As long as there's a CID representing the same image, the same file, the same piece of information, really, there is no need to preserve or to keep a second copy. And this is with regards to a storage provider. I want to qualify that point because one of the important aspects of properties of Filecoin and IPFS, we emphasize and we encourage folks to preserve more than one copy, but these are distributed across the globe. So you protect that single point of control and single point of failure. One thing I probably should just mention quickly, the barcode tags, this is how we represent data structures in the content addressable format, IPLD, which powers IPFS and Filecoin. So you just have a beautiful tree, and the root CID here represents the unique identifier or this content identifier, the CID. And each of these items or pieces here, they also have their unique fingerprints. We call these PCIDs. And then you have an aggregation of all this. This could just be in one folder. This could be in a separate folder. And then you have those aggregated. And then you still need a root CID that represents the entire data set or the entire digital asset. We've appreciated the duplication. So content routing, peer-to-peer. I mentioned communication and exchange of information on IPFS and Filecoin is in a peer-to-peer manner. So how does data get passed around, and how do requests really get processed? So we start with your peers, and they're here. Forget for a moment about IPFS and think of a group of people. If you want to address a person and communicate, it helps if you can identify them. For example, by their name, whether it's a real one, an alias, or another way of identifying them. If you share a common language, for instance, so that you can communicate, and if you have ways of verifying the identity, which is the name of this person, claiming, this person claiming that who they are and this is their identity and stuff like that, then it will be a very effective communication, right? Because you know this person, you can identify them, and you can even verify their ID and all that. So everything that they're saying obviously represents something legit, and it's important. So this is the same with IPFS and peers in the network. Each peer has a unique identifier, their peer ID, and this is linked to a cryptographic identity, which allows each peer to communicate securely through an encrypted channel. And we're here, the next one, my favorite topic, Filecoin. So what is Filecoin, and what is the relationship between Filecoin and IPFS? Filecoin, I look at Filecoin as simply the incentive storage layer, or the incentive layer on top of IPFS. Everything that we've just discussed about how content is packed in a content addressable manner, how peers communicate in a peer-to-peer, or nodes communicate in a peer-to-peer manner, no single point of failure, all these nice value propositions that we've appreciated about IPFS, all that still remains steady for Filecoin. It is the base, it is the platform or the basis. The only difference is there has to be an incentive layer or an incentive mechanism on top of that. You could call it data transfer or data transfer protocol for the new paradigm, because ideally that is what IPFS is. So think about IPFS, have those capabilities, and then have an incentive layer to bring in storage providers who have storage space, they have compute capability, like unused server space, and they're bringing this to what you could call a marketplace, a storage marketplace. That is the Filecoin storage network. They're availing these unused resources to anybody who has data and anybody who has compute needs. And in exchange, they get the native token called Phil from these folks with data, from these folks who want compute capability. So I avail what I have unused in exchange for tokens. You could think of that as just Airbnb for data storage. If you have some unused space and somebody else has data and they want to compensate you using some field to keep that data in a verifiable manner. So very important, in a verifiable manner. If I send my image to Michael being the node or the storage provider here, every 24 hours randomly, the network contacts Michael's servers and setup to ensure that he's continuously preserving my information. The first important thing is there is a unique copy of that data, and it is in the structure in the same manner that I provided to him, and then continuously, and we call that POREP technicalities. And then at the same time, every 24 hours continuously, Michael has to submit proofs, cryptographically verifiable, to the effect that they have space and they're continuing to preserve that piece. They're continuing to preserve my information or my digital asset. This is important because everything is represented and it is registered on chain. So you don't necessarily need an intermediary to ensure Michael has done his part and I have paid him by using the fill. Everything is controlled by smart contracts on chain. And this is just useful because it enables, any duration commitments, any duration. If I want to preserve this file even for 10 years, all I need to do is I need to keep renewing the storage deal that I initially made to Michael, and I need to continuously incentivize him to preserve the information. We've seen, yes, Filecoin is compatible with IPFS. You need IPFS as a building block, and then add an incentive layer or an incentive mechanism on top, and you have IPFS. Obviously, it's compatible with Web3. You'll hear a lot of this buzzword, Web3 and all that. It's folks attempting to build a new paradigm of computing, really, and the internet, communicating anything that you can think of and that you know about the internet, digital collaboration and communication. Folks looking at that through a different perspective. How can we give people more agency? How can we give people more control? How can this communication or this collaboration be permissionless, meaning you do not require central intermediary to give you access or even to invite you to participate and to collaborate on this network. Verifiable, like I have said, they're cryptographic proofs submitted the first time and continuously. And it is such a huge network across the globe. You have about 16 million terabytes of capacity across the globe provided by storage providers. And this market could even be more robust when we get to points where an unused space in my laptop, for instance, there is a smart and intelligent way for me to avail it to the network and get compensated to store people's data or run some other auxiliary services. So what is important really in all this is a deal. And I thought we should just appreciate the anatomy of a storage deal. To make a deal on Filecoin, you do need to convert the data from the original format. It could be PNGs, JPEGs, image, document, PDF, to a content addressable format, which is the format that is supported by IPFS, or more specifically, the Data Transmission Protocol, IPLD. And when you make this deal with, for instance, one or more storage providers to store your data, they, like I mentioned, they have to generate proof. The storage provider has to generate proof, and that's the second point we're making. And this is the proof of replication. It proves they have a unique copy of your data. And then over time, like I mentioned, they have to also, and this is done, it's randomized by the network. They also have to just continuously prove, hey, I still have space. Your unique copy, I still have it. I still have capability to honor your initial deal schedule requirements. And then these proofs make up the mechanisms by which miners or these storage providers are incrementally rewarded with fill. So you, like I said, you have to prove you have the unique copy, you're continuously providing it in order for you to get the reward. And if in any case, something happens and the storage provider is not able to submit these proofs, especially the continuous one, proof of space time, there is a penalty to them. Because before you onboard and become a storage provider, obviously the network expects their guardrails and safeguards, like just making sure any stakeholder that is on the network, if you onboard as a storage provider, we expect you to keep people's data and continuously support these cryptographic proofs. And to make sure that you do that, we expect you to also put up some collateral, commit this or stake this collateral on the network, which just gives people comfort and that guarantee that in the event something happens, you lose data, which has not happened yet, probably won't and shouldn't, or you just for some reason do not submit these proofs, then there's a penalty. There's a penalty. The storage provider could lose collateral and even their reputation. It takes a hit. And then toward the end of the deal, clients either renew this storage deal or they let it expire. And of course, when it is expired, there is a mechanism for storage providers to remove the data and clear the sectors on chain, so that even on the blockchain, there's a representation that has been removed. It's not an easy process, by the way, just so you know. Once you have data onboarded to Filecoin, it's not the easiest thing to delete it. It's not just a simple delete process. There is a process of destroying sectors on chain, and even that requires consensus from the participants or the stakeholders before it can be done. So when you're thinking about permanence, like I said, you have the ability to just keep renewing these storage deals. You could do it for a year, 5 years, or even 50 years, 100 years, if that's possible. And it's just simply looking at either the same storage provider, or if they're not available, any other storage provider on the network, make deals with them. And through verifiable cryptographic proofs, they continue to prove to you that your data is safe and it's permanently stored as a result. So redundancy, I mentioned this. This is important. Any deal that is made on Filecoin, there is an insistence. Actually, the practice is, make replicas, create copies. So have a copy in North America, for instance, have something else in Europe, have something else in Asia, or depending on geographical preference, or even within the same continent, have several copies. It's important. Again, that speaks to addressing the single point of failure or even the single point of control. And like I said, IPFS and Filecoins are buddies. The whole journey began with IPFS, and then there was a need for an incentive mechanism, incentive storage layer on top of IPFS to just bring in more stakeholders. So and there's a way you can actually use IPFS and Filecoin together. So Filecoin, in my mind, at this point, is suitable for long-term archival, slow retrieval kind of files. So these are the files that you want to put in a secure vault somewhere. Today, people use tapes, tape drives, or maybe there's something more sophisticated than that. You want to put that long-term and infrequently accessed. So you put your information on Filecoin, have it sealed. There's a basis to continuously provide these cryptographic proofs. IPFS, on the other hand, if you have needs for warm, faster retrievals, easy access to this data, you could still have your data formatted in IPLD, hosted in an IPFS node, and the same copies would also be sealed on Filecoin. So you can use the two of them, one to serve faster and warmer retrievals, which is the IPFS node or the network, and then the other one for slow, long-term archival. So why DWeb for cultural heritage? And because now we've seen what the decentralized web can do. We've seen what IPFS, briefly IPFS and Filecoin. We've appreciated some of those concepts of immutability, cryptographic verifiability, peer-to-peer network, resistance to single or sole point of control and failure. Now, we know that in the DWeb, files are distributed across nodes. You have more than one copy. This just makes it, like I've been saying, resistant to tampering and deletion. A single point of failure will not render like your digital archive moot. Globally, the global distribution and accessibility, there is a concept in technology, and this just even makes sense in real life. If something is closer to you, localization, if a piece of information is closer to you and you want it, you can access it faster compared to if your requests were routed continents away. So global distribution just brings this information closer to your audience. Alignment with the open access and digital rights. Like I mentioned earlier, I think this paradigm shift, this psychological shift, we need to get to more toward digital custodianship. We get even to a point where even if it's for public consumption, still the custodian can have legitimate control over who can access it and what they can do with the data. Yeah, I think those are the points to just repeat what we've been talking about. So I wanted to do a short demo to uploading, few files to one of the on-ramps, Storager. And this is suitable for smaller files. So if you have smaller files, Storager is suitable for that. Could you kindly confirm you can see my terminal?
Looks good.
All right. So the CLI is what we're using here, and I actually tried to do the demo. So this is easier because all my commands are going to be here. But before you can start uploading files here, I urge you to go to Storager's website. You can use the QR code and check out the plans they have, because sometimes if depending on the amount of data, they might want to charge you more. They might actually want to charge you. So if you have, I think, less than 10 GB or something, just look at the website and you'll see the plans. If you have less than 10 GB or 5 GB, I think it's free. And then from there are tiers, and also depending on the services you want. If it's an enterprise customer that is also looking for additional support, technical support, the rate is slightly different. But anyway, after you've settled on the plan, the next important thing is you have to create an account. Once you create an account and you associate that to your billing service, if it requires billing, then you're ready. And here, the first important thing you would do is create a space. So assuming you've logged in, you'd create a space. So I'm going to just check the spaces because I've already created the space for DPLA, but you can see some of the spaces I have here, Prailing Archives, MIT, all the way to DPLA. So I want to use the DPLA space because that's where I want to upload the files. So I can say space use and then DPLA. And by the way, on the website, all these commands and instructions are there. So now that I have access to, I'm focused on the DPLA space, I'm ready to upload my files. And it is a simple command, which is just W3 up, and then you provide the path to the files. And once I do that, I'd already uploaded that copy. So I'm expecting in the backend, we may not be able to verify that, but in the backend, they've not created another copy. And you can see how fast that just uploaded. So when the upload is done, like I said, each piece of information, each piece of digital asset uploaded to Filecoin or IPFS ends up with a unique identifier. And this is the unique identifier for that piece, the pieces that we've just uploaded. Because this is IPFS, which, like I mentioned, it provides you with warm or hot storage retrieval. They give you a whole link that you can just follow and check how the information looks. And I think Michael is going to spend some time showing us how to do this. So what I'm going to simply do is paste this in the chat for folks interested in just checking that out. You can check that out and see how that looks like, how the information looks like. Or very quickly, I could also just paste it on my browser and show you. So here we go. So it was a very small file, 2 folders. And if you go inside each folder, you can see you have an image, you have a metadata file. And if you also go to the next folder, is the same thing. So pretty much that, like, it respects and retains the structure of the information or the data, even after you upload it to Filecoin. I want to share my slides. There we go. All right. Then the next thing is challenges. Like I mentioned, it hasn't been a smooth sailing because it's technology we're building, we're exploring, we're trying out, we are learning even how people want to do things in Web3, how people want to store the information in a decentralized way. First of all, there aren't many tools that are easy to use, like user friendliness. You just saw me using a command line interface. Technical folks may not be spooked by that, but if you're less technical, that might be a bit of a challenge. Again, we've done our best to make sure documentation is clear step by step, and they even walkthroughs to just guide folks. And we're always available to provide support. Even these on-ramps teams from these on-ramps are always available to provide support. We've also done a very good job, both ourselves in the technical side and our program managers, creating communities that folks feel comfortable and safe, posting questions, sharing knowledge, just exchanging experiences. All the users and folks exploring this technology, there's a way for us to collaborate and just share experience. And that has helped. Lessons that folks have learned, others have skipped them or improved on them, fixed the gaps. And we are hoping over time things will be working seamlessly. That is not to scare you, but that is just to let you know there are challenges. It's a new frontier, it's a new technology. Maybe don't put production data or data that you expect to be integrated by or to production workloads, but any data that is meant for archival purposes, Filecoin is ready for that. And like I've just mentioned, you have these partnerships, you have technical support, the foundation creating this community and all that. And we value, obviously, feedback from users and folks so that we can continue improving it. So we have a lot of people using it. I actually believe this diagram is way out of date, but it gives you an idea of the growing list of both Web 2 and Web 3 products and services using IPFS and Filecoin. Yeah, and you can also appreciate just overall the Filecoin ecosystem, collaborators, developer tooling, infrastructure, all that. So if you do want to get in touch, there's a Slack channel, the Filecoin Workspace. We're available there. Our emails, mine is sankara@phil.org, and we can provide more information later through which you can contact us. There's always information, events, videos posted on our YouTube channel. Like it's important, reach out to our program managers, reach out to engineers at the foundation, and if you need anything, any help, they will be able to provide. I missed the last slide, which was supposed to be Q&A, but that is essentially the end of my presentation. So I invite any questions.
I can also let Michael give your presentation, and we'll see if anyone has any questions. Please feel free if you want to put anything in the chat now.
Sure. Yeah. So I think I'm here to just show what this looked like. This collaboration that we underwent with the Filecoin Foundation looked like from the DPLA side. Essentially, we chose a collection of items from National Archives that had unrestricted licensing on them, and Sankara and I worked together to retrieve those from National Archives and to combine them with the DPLA record for the item. And embedded in the DPLA record is the National Archives record, so it's sort of a twofer there. And Sankara, we transferred the data to Sankara. Sankara took care of uploading a smaller set of the overall set for this presentation and placed it in decentralized storage. And then as part of that was minting those content IDs, which he transferred back to me, and I was able to join that back with our original records in our search index. And so for the initial set that we threw together to make this work, that those records on DPLA actually do have links to the data in storage. So I'm just going to share the DPLA interface right now quickly. You can see this is a picture of Admiral Michelle J. Howard, who was, among many other milestones, was the first 4-star admiral of the U.S. Navy. And so presuming that we want to, keep and preserve this, in this particular case, obviously you can go to National Archives and view the record there still, but we also created this other button for this record that allows us to see the record as it has been stored in Filecoin. And so you can see that that generated a IPFS link with a content ID in it, which is this large string here. And in this particular case, this item only had one media asset, which is the full frame photo as a JPEG. But also we have the metadata record here as well. So this is DPLA map metadata, and you can see the National Archives XML record inside here in the original record field. Maybe I can see that. It's not syntax highlighted, so it might be hard to see, but you can see it in here. That's an example of a single frame. Many of National Archives records contain multiple frames. In fact, there's some items in National Archives that are over 10,000 pages of TIFFs and can be rather enormous. I chose another record in DPLA, which is part of a documentary project that the Environmental Protection Agency underwent to record media of important environmental sites that might be threatened for future generations. So that's this particular Monterey photo. And if you look at it in Filecoin, you can see that there are actually, let's try that again. Sorry, I'm not quite sure why that's not pulling up. Okay, well, that's my bad. Apparently that one hasn't fleshed out yet, but I could have sworn it was there just a second ago. Anyway, what we did was we chose to use this format where in the metadata there's a field that represents all the different captures for that particular record. They might be pages, they might be different formats or different levels of fidelity in terms of the media, and we created a kind of a sequence number for each of them as they appeared in the record, and we uploaded them all. So you can see, like, if you land on the directory for an item, you would see 1, 2, 3, all the way down to whatever it might be, 10,000, might just be 4. All of those particular media files, and then the metadata record that describes what the item is in a descriptive context. And so essentially we are able to take these IPFS and or Filecoin links and join them back to our records and kind of keep those things together so that stuff is accessible and findable by anyone that might want to draw from it. So yeah, that was pretty much what I came to show everyone. Thanks.
Great. Thanks so much to both of you. We'll give it another minute to see if anyone has any questions. Please feel free to send any in. And if not, we can end a little early. Do you want to give your contact information again?
Yes. You can reach me through or from Filecoin Slack, the workspace, and Sankara let me just type it quickly, at phil.org. That's my email address. Or my colleague Breen at phil.org, just pasting that as well.
Great. Thanks so much. Thanks so much to the Filecoin Foundation, and also thanks to everyone who joined us today.